Life is chemistry. Dilute your sorrows, evaporate your worries, filter your mistakes, boil your ego. You will get the crystals of happiness. Hello everyone, welcome back to today's video. In this video, I'll be posting some questions. I want you guys to read those questions and send me the answer. And I'll be very excited to see your answers. Please leave a comment about this video. Let's continue with our lesson. Question number 1. Why is sodium kept immersed in kerosene oil? Question number 2. Write equations for the reactions of iron with steam, calcium and potassium with water. Question number 3. Samples of 4 metals A, B, C and D were taken and added to the following solution one by one. The results obtained have been tabulated as follows. Use the table above to answer the following questions about metals A, B, C and D. Which is the most reactive metal? What would you observe if B is added to a solution of copper 2 sulfate? Arrange the metals A, B, C and D in the order of decreasing reactivity. Question number 4. Which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write the chemical reaction when iron reacts with dilute sulfuric acid. Question number 5. What would you observe when zinc is added to a solution of iron 2 sulfate? Write the chemical reaction that takes place. Let's say that you are in a contest. To win the contest, you should have 8 chocolates in your hands. Let's say, for example, that Mr. Sam has 9 chocolates. So what should he do to win in the contest? On the other hand, Mr. Zack has only 7 chocolates. So what do you think that they should do to win this contest? This is what they should do. Mr. Sam should lose 1 chocolate so that he has 8 chocolates, and Mr. Jack should gain that 1 chocolate. In this way, both Sam and Zack will have 8 chocolates. So both of them could win a contest. This is what is happening in real life too. But instead of chocolates, we are going to talk about electrons. I know that you have learnt about electronic configurations in your lower classes. Come on, let's see about their applications here. Noble gases or elements which already have 8 electrons. I think you know by the octet rule that if an element should be stable, it should have 8 electrons in its outermost shell. So, noble gases already having 8 electrons are stable, and it's not necessary for them to lose or gain electrons. This makes them inert, that is, non-reactive. Hence, they are called inert gases or noble gases. Let's see the configurations of neon, helium and argon. Note, helium has 2 electrons, but still it is stable. Neon and argon have 8 electrons in their outermost or valency shell. Up next, metals are very reactive as we have seen earlier, and they are unstable too. Let's take sodium for example. As you know, its atomic number is 11 and its electronic configuration is 2, 8, 1. So, 1 electron in its valency shell. Sodium loses that electron attaining the electronic configuration 2, 8, that is 8 electrons in its valence shell. But there are always same number of protons and electrons in an atom. So, in sodium, there must be 11 electrons and 11 protons in an atom. As sodium loses 1 electron, an electron decreases and becomes 10 electrons and 11 protons. So the number of protons or positively charged particles is more. So sodium gains a positive charge and becomes Na plus, that is sodium cation. I know it's quite complicated, but try to watch this part of the video again and again. If still you don't understand, please feel free to ask me. Similarly, the nonmetals have more number of electrons in the valence shell. They can't lose their electron, so they gain electrons. Let's take chlorine for example. Its atomic number is 17 and its electronic configuration is 2, 8, 7. So it needs one more electron to attain stable electronic configuration. So what should it do? It gains the electron which was lost by sodium, and it gains 8 electrons in its valence shell. But now it has 17 protons and 18 electrons. So more number of negatively charged particles, right? So it gains a negative charge and becomes Cl minus or chlorine anion. Now I think that you have learned that opposite charges attract, right? Here Na plus and Cl minus are oppositely charged. So an ionic compound is formed, that is NaCl or common salt as you know it. It is called an ionic compound since it has a positive ion, that is cation, and a negative ion, that is anion. Formation of magnesium chloride. Now let's see about the formation of another ionic compound called magnesium chloride. Now magnesium is the metal. Now magnesium is the metal, okay? As we have already seen, it should lose a few electrons to form a cation. Let's see about their valencies. Now magnesium's atomic number is 12 and its configuration is 2, 8, 2. So 2 electron in its valency shell, right? So it needs to lose 2 electrons to attain stable neon configuration. So it loses the 2 electrons forming Mg2 plus cation. Then coming to chlorine, we know that its atomic number is 17, right? Now let's come to the question. Magnesium has lost 2 electrons, but chlorine just needs 1 electron to become stable. So what can we do now? Maybe we'll add another chlorine atom. So in this way, we can utilize the electrons released by magnesium, thereby forming magnesium chloride, which is the ionic compound we need. Let's move to the next topic, properties of ionic compounds. As we have seen the properties of metals and non-metals earlier, we are going to see about the properties of ionic compounds. Property number 1, the physical nature. Ionic compounds mostly exist as solids and are somewhat hard. This is due to their ionic nature or the strong force of attraction between positive and negatively charged ions. These compounds are brittle and break into pieces when pressure is applied. Note: the individual properties of the elements present in the compound are completely different from the properties of the compound. For example, sodium chloride. Na is a soft metal and Cl is a gas, whereas the compound of these two elements, that is sodium chloride, is powdery and salt-like nature. I am sure you can see the difference. Property number 2. They have high melting and boiling points. This is also due to the strong interionic force of attraction. Property number 3. Solubility. Ionic compounds, also known as electrovalent compounds, are generally soluble in water and insoluble in solvent like kerosene and petrol, etc. Property number 4. Conduction of electricity. If a solution should conduct electricity, then the charged particles in the solution should be in motion. It is not possible for the charged particle to move due to its rigid structure, but ionic compounds could conduct electricity in molten state. This happens due to the heat. The heat enables the ions to overcome the force of attraction. Thus, the ions move freely and conduct electricity. Okay guys, that's all for today. Meet again in the next video. Until then, bye from your Esther Miss. Bye.